Now in this video, we're going to talk about motion in one dimension. We will take each of these terms, which is displacement, velocity, speed, and acceleration, and talk about it in detail in our subsequent videos. Take note of this. Mechanics is the science that deals with motion of objects. Now it is the basis to all branches of mechanics or physics. Now the branch of mechanics that describes motions of objects is called kinematics. Now, in this branch, we answer questions like, does the object speed up, slow down, stop, or reverse directions? So these are some of the questions that we answer in kinematics. Now, another one is, how is time involved in this situation? This is another question that we also ask. Now, in this video, we are only going to take our study on motions along straight lines. So the moving object of concern is either particle or an object that can be viewed to move like a particle. So let's first talk about position and displacement. Position and displacement. Now, to locate an object in one-dimensional space, we find its position with respect to some reference point called the origin of axis. Now, such as with this one that we have here. So I have this diagram here. So the positive or the negative direction of this axis here is the direction of increasing or decreasing numbers. So a change in the object position from the initial position, which is the xi. So we take the initial position to be xi. So initial position to be xi. And the final position to be xf. Right, it's called a displacement, which is read as the delta x. That's the change in x, right? So with the blue color here that I have here, that is the negative direction. So this is the negative direction. And with the red, that is the positive direction. So that's the positive direction. That's where the particle is moving. So a particle can move in the positive direction or in the negative direction. So the position of a particle that moves in one dimension is identified on this x-axis that is marked in a unit of length. Right. Now, so what is the formula for displacement? So the formula for displacement is delta x is equal to xf minus xi. Right, so that is the final position minus the initial position. Right, so the displacement is a vector quantity, which means it has both magnitude and direction. So the magnitude is the distance between the initial and the final position, and the direction is just by so the direction is what I represented here, which is the positive direction or the negative direction, right, by a plus or minus sign for motions to the right or to the left respectively. So motion that is moving to the right is the plus sign, and the one moving to the left is the negative sign. So with this one is the negative sign, and this one is the plus sign. Right, that's what we use to represent that. Another thing that I want to talk about in this video is average velocity and compared to average speed. So let's first talk about average velocity. And with this one, I'm going to use this diagram to explain things here. So you have to pay much attention here. Now let's consider a particle moving along the x-axis. So this is the x-axis here. So a particle is moving along this x-axis, right, where its position time graph is shown here. So this is the position. So this is the graph that I'm going to use to explain that. So at point P. So this point P. At point P, let its position be xi. That's the initial position. When the time was ti, right? And at point Q, so this point Q, let the position be tf, right? So xf rather. So at position Q, let the position be xf when the time was tf. So the indices I and f just refer to the initial and the final values for the variable under consideration, what I'm talking about here. So accordingly, during the time interval, which is the delta t, which is equal to the final time minus the initial time, the particle's displacement is delta x equal to the initial final position minus the initial position, right? So one of the several quantities associated with the phrase how fast a particle moves is the average velocity that I'm talking about here, which is defined as the following. So with the average velocity, which is v, right, of a particle is defined as the ratio of its displacement, the ratio of its displacement. So what is the displacement here? That is delta x, right, to the time interval. And what is the time interval here? Delta t, right? That is, the average velocity is equal to delta x on delta t. And what is delta x? Delta x is the final position minus the initial position. And what is delta t? That's the final time. So that is tf minus the initial time, right, that we have here. So from this definition that I just mentioned, or I just put here, v, which is the average velocity, has the dimension of length divided by time. That is, which is, the unit is m/s. That is meters per second in SI units. So the average velocity is a vector quantity which has both magnitude and direction, and can be represented by plus or minus sign for motion to the right side and to the left side as well, right? Now let's talk about another thing here, the average speed. What is the average speed here? Now the average speed, which is represented as x then with a dash on top of the x, is a different way of describing how fast a particle moves, and it is defined as follows. So we are going to compare both the average speed and the average velocity, how it works. So with the average speed of a particle is defined as the ratio of the particle, is the ratio. So let me just write here. So the ratio of the total distance covered, which is d, to the time interval. The time interval, that is delta t, right? So where delta t here is equal to the final time minus the initial time, right? So let's write the formula well. So with the formula of average speed, we have total distance. So here we have total distance on delta t, right? So we have d on tf minus t initial, right? So that is the formula for average speed. So the average speed here is different from average velocity in that average speed does not depend on direction at all. So the difference between the average speed and the average velocity is that the average velocity has both magnitude and direction, but the average speed does not depend on direction. So let me state it again. The average velocity has both magnitude and direction, but the average speed does not depend on direction. Hence, it's always positive. It's always positive. So in average speed, we don't have negative or what we call positive. It's just always positive. Just know that average speed is always positive. But average velocity can be both positive or negative depending on the direction where it is going, right? So in some cases, average speed might be the same as average velocity, because when the average speed is positive and the average speed is positive, therefore they are the same thing, right? So now let's take some example here. Let's take some example to know whatever we just explained here. So with this example, we have a car moving along the x-axis. Starts from the initial position to be 2 meters, when its time, which is the initial time, is 0, and stops at the final destination, which is -3 meters, when the final time is 2 seconds. Now we are going to find the displacement, the average velocity, and the average speed during this time interval. And the B says that if the car goes backward and takes 3 seconds to reach the starting point, then we should repeat the questions in A. We are going to find the displacement with that, the average velocity with that, and the average speed with this one too. So let's start with our solution. So our solution here. So with our solution, the first thing that we need to find is the car displacement. So if you know the formula here, the displacement. So with the displacement formula, so what is our displacement formula here? That is delta x, and delta x is equal to the initial position, that's the final position minus the initial position here. And what is our final position? So let me just clean this one and write. So our final position was -3 meters, and our initial position was, that's 2 meters. So what is our displacement? Delta x is equal to -3 minus 2 meters, right? So our displacement will be equal to -5 meters. All right, so that is the displacement of the car. That is -5 meters. Now let's calculate the average velocity. That is which will be delta x on delta t, where we have delta s to be final position minus initial position on final time minus initial time. So with this, we have -3 meters minus 2 meters on 2 seconds minus 0 seconds, right? Then our average velocity will be equal to 5 meters on 2 seconds. That will be -2.5 meter per second, right? So that is that. Now, since the delta x, which is the displacement, and the average velocity are negative for this time interval, then the car is moving to the left towards the decreasing value of x. So when we go back here, let's go back to the diagram that I drew here for this one. So the car is moving towards this direction. The decrease on the x-axis. That's why we have both the displacement and the average velocity being negative. So let's go back to our question. So yeah, so the total covered distance will be, the total distance covered will be 5 meters, right? And the average speed will be equal to total distance on delta t. So we have 5 meters on 2x minus 0x. Then we will have 5 meters 2 seconds, which will be 2.5 meter per seconds, right? So that is our average speed. So this is our average speed. So here you can see that we got the same value for both the average velocity and the average speed. But here, because average speed has both direction and magnitude, it is assigned negative here, which means it's moving in the decreasing order on the x-axis. But here, average speed has just magnitude but no direction. It does not depend on the direction, so we just have the value of 2.5 meter per second, right? So in this case, s is the same as v, which is the average velocity, except for the minus sign. So when you have the car, so let's say we have the x, so let's just draw the x-axis right here, right? And let's say we have the car, let's say this is my car right here with a tie, right? And let's say this is the -3, -2, -1, 0, 1, 2, 3, right? And the car was starting maybe from this side, right, with my tie right here, right? So this x in meters, right? So the car will be moving in this direction rather, because we have the average velocity to be -2.5 and the displacement also being negative, which means it's moving in the direction of decreasing order in the x-axis. Now let's take the b. The b is saying that after the car moved backward movement, so the final position and the final time of the car should be xf should be 2 meters and tf should be 2 seconds plus 3 seconds, which will be equal to 5 seconds, right? If you understand, because in the other way the car moved front, like let's say it was moving forward in 2 seconds, then coming backwards it took 3 seconds to move backwards. So when you add both time together, the total time should be 5 seconds, right? So while the total distance covered here, so when it took the car 5 meters to move forward and it took 5 meters to move backwards, so when you add both distance together, the total distance covered should be 5 meters plus 5 meters, which will be 10 meters, right? So as we know, the displacement involves only the initial and the final positions, and that will be delta x will be in final position minus initial position, which will be 2 meters minus 2 meters, which will be 0 whatever, so 0, right? And then the average velocity will be change in x on change in t, which will be xf x initial, then tf t initial, then we have 0 on 5 seconds minus 0 seconds, which will be 0 second. Now finally the average speed here. So with our average speed, we'll have the total distance on the change in time. So the total distance, we know that is 10 meters. Then with our change in time, we have 5 seconds minus 0 seconds, which will be 10 meters on 5 seconds, which will, our average speed will be 2 meters per second. So as you can see, the average velocity is 0, while the average speed is 2 meters per second. since the latter depends only on the total covered distance. That's the reason why we have this answer here, right? And this is the end of this video, and I'll see you in my next video where I'm going to talk about instantaneous velocity and speed. Thank you for watching this video.